Hi, Computer Science 120A students. So, let's do a little bit of a live programming session where we'll get to know how we can use our Linux computer to do a little bit of programming and also get to know the C++ programming language. But before we start, know that everything that I will do will be on a Linux computer, and we need to put some software on that Linux computer, and we've given you tips on how to do that. So here on our Canvas page, there's a page here called Linux Setup, and it gives you some information about how to do it. This command right here, if you put it into your Linux computer's terminal, it will install the software you need for 120A and 120L, and you won't need to lift a finger. Everything is just taken care of for you. Now to do this, to demonstrate, I won't do the whole thing. It takes about 10 to 15 minutes, but to do it, we just need to take that command and type it into a Linux computer. So what I'm going to do is I'm going to switch over to my Linux computer. As you can see, this is my Linux computer, and what I need to do first is to get a terminal. Now this might not be as obvious, but if you right click anywhere on the desktop, there's open in terminal, and if you do that, up comes a terminal. Now if this text is a little bit too small, you can always come up to this menu right here, and you can click preferences, and you can go to the profile. Go to your current profile, unnamed, and change the font. Right now it's a monospace 12 point size, and I can click custom font and make it larger. Let's make it 18. So select, and now it's a lot bigger. Feel free to adjust this however you want, change the font, make it colorful. I'm just going to show you that you can make the text larger. Now, like I said, that web page had that command, and I'm going to, I've got two computers working, so I can look at that command on, say, my other computer or my phone or my iPad and be able to type out that command. So if I type out wget -q and that long URL that's right there, and it's okay if it goes off the end, it'll just wrap it around. And that's a -O, not a 0, -O with a dash, and then a space, and a bar. The bar key is right above the return key on your keyboard, and then that's SH. Now before I hit enter, I'm going to just double check to make sure I typed everything in correctly. Now if I didn't type it in correctly, let's say I have some gobbledygook right here, it's okay. It'll just say it doesn't work or whatever. It just does that. Nothing will happen. If something like that happens, it doesn't happen. Or you type this part okay, but oops, I messed it up. If you type this part okay, but you type some junk over here, it will say something like that. It's not a big deal. When you do it correctly, when you got everything typed out just right, and you type this, it's going to do that. It's going to ask you for your password. Now, the password you type is the password for this computer that you're on right now. So when you set up this Linux computer, you select a password. Ideally, you still remember it. If you don't remember it, that's a problem. There's no way for me to know what that is. You might have to do the whole installation over again. But so make sure when you set the password for your computer, you remember it. Now, I remember the password for this computer. It's okay. So once I type that password in, it's going to check to make sure it can install software. It's going to remind you that it's going to download a whole bunch of software, and it's going to give you 15 seconds if you to decide if you want to abort. If you do, you can push Control C, and that aborts it. Control C at the same time will abort what you're doing. So it just has a 15-second pause to give you that chance to stop in case you're not sure what you're doing. Anyway, I'm pretty sure I want to do this. I'm going to do that. And it's going to count down the 15 seconds, and then it's going to go through this process of installing all the software. And that includes the compilers, the debuggers, Visual Studio Code, all the things that we need to be productive this semester. So it will scroll by and do all sorts of magical things. You'll know it's done when you get the $ prompt back. All right, so it took about 5 minutes to run, and I see the dollar prompt is back, and I have my cursor. I don't see any error messages. I think everything worked just fine. My computer's still here. Everything's working. So I'll just assume it worked. Now, if we find out it didn't work, well, we can always run this script again. We can always go talk to our TA or our instructor to get some assistance. But if you don't see anything that says error or warning or it looks like it finished, just assume that it worked. And you can find out if something's wrong just by writing a couple programs or writing a program or trying to do your homework, and you'll find out pretty quickly that it works or it doesn't work. So let's assume it worked, and let's try writing a program. Now, one of the most important tools is this terminal. And you don't have to have just one terminal. If you want, you can open as many terminals as you want. I've already shown you that you can right click on the desktop and you can say open in terminal, and it'll open up another one, right? Another thing you could do is you can also create tabs. So you can click that. Now I've got 2 tabs that I can switch between. But just to keep things simple so I don't have too many things going on, I'm just going to use one. But feel free to make as many as you want at home. Now, one thing that you might want to do is to learn a few keyboard shortcuts and some commands. The first one I'll show you is a fun one, which is if you hold down the control key and push L, it'll clear the screen. Sometimes it's nice to start with a blank slate. The prompt here has a $sign. That tells me that it's a bash shell. And over here is some information about my computer. That's my username, mshafei, and it's on this computer. And this part right here in blue will tell me where I am in my computer. The tilde character, which is the character that's in the upper left-hand corner of your keyboard that looks like that, right? That's a tilde, T-I-L-D-E. That means home. That's your home directory. So here it's telling me that I'm in my desktop folder of my home directory. The way we know where we are, we can type pwd, and that tells me the fully qualified path. That tells me where I am on my computer. And it's very similar to like how we might explore our computer with our keyboard our mouse and one of these graphical user interfaces where I can double click things and move around. So this is me in my desktop folder, and I can go back to my home directory and go to the music folder and find out there's nothing there, on and on. You've done this before on Windows or a Macintosh. Same idea here on Linux. But we want to learn how to do it from this terminal. So pwd, that stands for print working directory. That tells me where I am. Another command is cd, change directory. cd, and I can tell it to move someplace. Well, if I want to just go to my home directory and I just type cd, it will take me there. If I type pwd, it'll show me that I'm in my home directory. Your home directory is always I shouldn't say always, most of the time, /home/ your username. In this case, my username is mshafei, so that's why my home directory is named that way. And if I type ls, it'll show me what's in my home directory. That's like listing out. ls stands for list, listing. And if I want to change directories, I can type cd space and then type out any of the names. Let's say desktop, desktop. That'll work. If I type ls again, you'll see there's nothing there because there's nothing on my desktop. To go back to the home directory, I can type cd. That's basically it. Now, if you type something wrong, so let's imagine we type ls, and I want to cd into my documents folder. I might type cd space, and let's imagine I don't uppercase it. Well, it won't work because capitalization matters. It is case sensitive. And let's imagine I do capitalize it, but I forget the S. Again, it won't find it because the computer can't figure out what I intend. I have to be very precise. A lot of times people are they don't like this experience because you have to be very specific, but oftentimes there's shortcuts that help you be specific very quickly. So if I type cd and I realize that documents, DOC, is the first 3 letters that are unique. Notice that there's D appears in 3 different folders, 3 different directories, desktop, documents, and downloads. DO appears in two of them, documents and downloads, but DOC makes this one unique. So if I type DOC and then I push tab, the tab key is on the left-hand side of the keyboard. If I push it, the computer, the terminal, will fill in the rest for me, so I don't have to type out everything. And if I want to go back up one directory, if I just CD'd into a directory, I want to go back out one, I can type CD space ... And you can see I've gone back out to my home directory. CD documents, pwd, CD space ... takes me back out one directory. Let's try making a directory. That's mkdir, make directory, and we need to give it a name. Well, we're going to be working on stuff for Computer Science 120, so why don't we call it CPSC 120. If I type ls, you can now see there's a directory that's named CPSC 120. I'll type cd space CPSC 120. Hit enter, and you can see now I'm in that directory. Let's try writing a program. I recommend that we learn how to use Microsoft Visual Studio Code. It's a very popular text editor, and if you ran that script that I ran earlier, it will install it on this computer. So to get it working, I type code, and then I specify the name of the file I'd like to make. And the program I want to write, let's think of something really simple that we can write a program for. And something really, really simple would be calculating the area of a rectangle. You probably remember that calculating the area of a rectangle is like length times width, and we can write a simple program that does that. So I'm going to call this program rectangle underscore area.cc. That's another tip. We don't really want to put spaces in file names. That's something that you might do on your desktop computer, like in Windows or on Macintosh, or the files that you save in Google Drive or Dropbox. But when we're working with stuff in code or on a terminal, we really don't like spaces. So if you ever need to put a space, use an underscore or a dash. Those are the best choices. So here I'm typing in a new command, code. That's going to open up Microsoft Visual Studio Code. And I'm going to create a new file called rectanglearea.cc. And this is Visual Studio Code starting up. Now, just like the terminal, I can set preferences to change the size of the text and make it look and feel the way I want. I recommend moving your windows around and making sure that they don't overlap. It's really awkward to have everything stacked on top of each other. You have to switch back and forth, and that's awkward. So it's better if you've got enough screen real estate, move the windows around so that you can see everything and be able to move just your head or your eyes and switch between them. Now, as you can see over here, it says at the top, restricted mode is intended for safe code browsing. Trust this window, enable all features. Yes, we want to trust this window. So we're going to say, I think manage. We're going to say trust. This will enable all features. Then down here, it says, oh, do you want to add the C++ extension? Sure, why not? And it's installing it. Blah, blah, blah. It'll give it some extra doodads and doohickeys for when we're coding. Now, look across the top right here, and there's my file, rectanglearea.cc. If I click that, I will get absolutely nothing because it's a blank slate. So let's write a program. The first thing that we do is we need some pound includes. And we're going to pound include IOStream a lot. Oh, wow, this text is really small. Let's see if we can make the text larger. Here we go. Font. Let's change the font to 18. Let's see, did that make that large enough? That looks a little bit better. Let's make it a little larger. Oh yeah, that's nicer. Okay. So all I did there was I just clicked twice on any one of these icons to get rid of that sidebar, so I have a little bit more space. I'm just going to get rid of that. Let's start with our pound include. Then we need a main function. We can leave this empty for now. In class, we've talked about what we put between the parentheses, but we can just ignore that for now. And I want to write a program that does area. So I want to take length and width. Let's imagine that I've got a rectangle that's 7 units, 7 feet long, and it's 5 feet wide, and I want to calculate the area. And the way we would do this was, well, we might just type out the mathematical expression. I want, I think I said 7, and I said 5, and that will calculate it. But that's not very useful because we want to store the results someplace. And we might want to change this program later. So let's imagine, let's say I want to have a variable, a name, that's called length, and I want to initialize it to something like 7, for like 7 feet. So far so good, but an important part of making any variable is like the compiler needs to know, what is this? Is it a number? Is it a word? Is it something else? And so what we have this concept in C++ of types. So we'll call it an int type. That's telling the compiler and me and you that this word length means that it's a number because the type comes right before it. And here, this is an operator that means assign to or copy onto. It's copying 7 into length. So length is a number, and it didn't mean anything other than a number, and I copied into it 7. And that's a very traditional way of doing it, but it's not a very C++ way of doing it. The modern C++ way is to do this, is to use braces. That's called an initializer list. And that's just the nicer way of initializing or creating a variable called length that's of type int, and initializing or creating it with a value of 7. Let's make another variable, and since we're doing rectangle area, we want length and width, so we'll just do the same thing, width, and we'll say it's 5 feet. Now, VS Code does a lot of this highlighting stuff and color coding things. A lot of people like it. I think it adds a lot of noise, especially when you're learning. So if it gets in the way, just ignore it. Just focus on what you're thinking about, what you're writing. Remember, this is just a tool. It doesn't know anything more than you do. So don't try to read into its behavior to say, oh, it's telling me to do this. No. You're the driver. You're the pilot. You get to decide what's happening. So far we've written 2 lines of code inside of our main function. Remember, our main functions are entry point. That's where the program's going to execute. I have a variable called length. It's of type int. That means I can store numbers like 7, -0, sorry, -7, 7, 15, 0, any of those things. And I've got another variable width. It's also an integer, and I'm storing in it a number. And the braces are a way of me creating variables with values. Well, I also need to know the area because I want to calculate something. So I'm going to make another variable called area. And I'm also going to initialize it to the product of length and width. That means I'm going to say length times width is what area is going to be when it gets created. I'm initializing it with this expression. This arithmetic right here gets executed and converted to some value, and it's stored into area as it's being created, and that's why it's being initialized. There, that's an exciting program, but to show it to the rest of the world, I'm going to need to print it. And to print something in C++, we use cout for console out, and I use this operator, the insertion operator, to be able to send text to my console. The console is the terminal. So I'm going to say the area of, and I want to say what I just want to be pedantic. I want to tell the world what I actually did. So the area of length times, and this is a neat thing. I can mix words with my variables just by using this insertion operator right there. I can say I want to send this to the screen first, and then I'm going to send this variable, and then I can continue typing. But this is going to go off the edge, and that's going to look awful. So what I'm going to do is I'm going to break up this line by just formatting it nicely so that it's easy to read. I'm using the X here on this line, line 9, to mean multiply. I'm going to say width is area. And I probably could squeeze this in more on one line, but I was just breaking it up on alternating between variables and strings. If you wanted to, you could, put more stuff on the line together. For instance, I can squeeze this in without going off the end. Let's squeeze these guys together. Ultimately, you want things to look nice, easy to read. That looks like it's nice and easy to read. Oops. And then finally, last thing we do is we say return 0, because if we get to the end of the program, if we got this far and everything's okay, that means things are good. Now, out of reflex, I already saved with the keyboard shortcut, but you got to remember, as you're working, you got to click save. You just got to save your work. If you don't save your work, it won't be written down to the disk, and the compiler won't see the changes you made. So over here, back in the terminal, if I type ls, you can see there's a file here. And the contents of that file is what I have over here in my text editor. Now to convert this into a program, I'm going to use the compiler. In our case, we're using Clang++. And I give it the name of the file. Oh, and did you notice how fast I typed there? I pushed tab. It filled it in for me. You want to see that again? So if I delete this, if I type R, E, and then push tab, it'll fill it in. And once I hit enter, it's going to think for a second and give me back the dollar prompt. And how do you know it worked? Well, in this world, in this Unix world, using these shells, if it doesn't print anything, it means everything worked out okay. No news is good news. If I type ls, you'll see there's the file rectangle area. That's what I'm looking at over here. And there's this new file, a.out, which is my program. That's been converted into a file that the computer can execute and run. If I type /a.out, it's going to do exactly what I just told it to do, which is to take 7, multiply by 5, get the result, store it in another variable, and then print all of this out. Now, this program is not very flexible. If I want to figure out something new, I'd have to come back over here to this program and change it. Let's say I change it from 7 to 58, and I'm going to take the width and change that to 99. I go up and say File, save my work, and now I have to recompile it because I made those changes in the source code. To see those things actually happen, I need to recompile it. Now, to demonstrate, notice that I've changed the code, saved it, but if I run that program again, it's the old program still. I have to run the compiler one more time. Now, notice I'm going backwards and forwards through these commands. The way I'm doing that is using the arrow keys on my keyboard. If I push the up arrow, it will take me to the previous command. If I push it again, it'll take me to the previous command, and one more time takes me back to that command. It saves me some time. I don't have to type out the whole command again just by using the arrow keys. Push enter, thinks for a second, compiles, and now I can use the arrow keys again to find my /a.out. Hit enter, and now you can see 58 times 99, well, that's 5,742. Okay, so now we've changed the program, saved it, recompiled it. It works. So this tells me that I've got all my development tools installed on my computer and everything's good. Now, shall we try writing another program, like a different one that's maybe a little bit more interesting? Why not? So how about we write a program that calculates the area of a circle? I'll call it circle area. All right, so VS Code says, do you want to allow untrusted files in this window? And I'll say, yeah, let's open it. So I've got this new file. I'm going to do the same thing again. Start with a pound include. I need IOStream because I want to be able to print to the terminal. I need to write my main function because, well, that's the entry point to the program. But this time I'm doing the equation for, well, I'm doing the formula for an area of a circle. And the area of a circle, if we remember it's pi r squared. So I need to have a way of representing pi. And, for the sake of this program, we can say it's 3.14. That's fine. We don't need to have like a really precise estimation for pi, but 3.14 is good. But we can't express pi as an integer. I can't say int pi because I only could initialize it as 3. Look what would happen if I did pi with a 3.14 and an int, and then I printed it out. Let's see what would be printed. Now remember, the \n just means new line. It's the way that I can get the cursor to move to the next line, and that way it looks nice when I print it. So I've declared pi as an integer, and I've given it something that I think might be nonsensical because an integer doesn't have decimal places. So I'm going to come up here, save this, type ls. Yeah, I see my file, circle area. I'm going to compile it. Oh, look at this. So this is where the compiler is telling us that there's some type of problem. Because look, big red letters, error. Okay, so let's try to understand what they're saying here. Type double. So there's another type. So integer is one type, double is a different type. Integers are numbers like 5, 17, -12, 0. Those are all integers. Doubles are numbers that have decimal places. Pi, 3.14 in this case, where our approximation of pi, is a number with a decimal place, and so we have to use a double type, not an integer type. So our compiler is telling us, I'm trying to fit a square peg in a round hole, that I can't take a double, 3.14, and put it into an integer. So it says either, sometimes it'll give us bad advice. This is not good advice. We don't want to do this. So please don't always just blindly follow the advice that comes out of these machines. You just want to try to understand the best you can what the error message is about, and then make the best decision you can, but just don't blindly follow their advice. So our problem is, this is a double, but I'm initializing a variable that's of type int, and the types don't match. And that's a very important rule to remember. The types must always match. So I'm going to change this to double. Oh, and we got to save our work. And we'll compile. Again, I'm using the arrow keys. Let's try running our program. Hey, it prints out 3.14 as we expected. So let's come up with the radius. Now, I could think of the radius as an integer. Sorry, folks. But why don't we just think of the radius also as a double? That'll give us flexibility to have a radius expressed as a decimal number, but also not as a decimal number if we don't want. So I can say my radius is, 7.0. And now I can do my calculation. So my my area, remember, a double times a double is going to be a double. We have to think about how these operations, when I work with types, when they work together, what comes out of it. And if I take a double, pi, and I multiply it by radius, that's going to give me another double. The type doesn't change. Now this gets tricky with division, because I could take an integer, say 3, and divide it by 4, another integer, and 3 divided by 4 doesn't give me an integer, it gives me a double. So this is why it's important to think through the relationships of these operations and these types to make sure we're selecting the right type. So I want to do the area. The area is pi r squared. So pi times, okay, so in C++, there is a POW function, but it's not a good choice for when you just want to square something. So to square something, I'm just going to take radius and multiply it by itself. That's the easiest way you can square something. And there we have pi r squared. Yeah, that'll give me the area. And then let's print a nice message out here. Oops, forgot the quotations. Oh, with the radius is area and period. That looks good. Oops. Let's come over here. Let's save our work. Let's compile this. Just using my arrow keys to go back through my commands. And the arrow keys once again. The area of a circle with a radius of 7 is 153.86. That's not bad. It does the calculations, and I get the decimal places. And when it printed out radius, notice this. Here I initialized radius as 7.0. But when it printed it out over here, it didn't say 7.0. Instead, it just said 7. That's really nice and flexible. Let's make another change. Let's say our radius is 123.456. Let's see what would happen. Again, I go up to here to File, Save. Oh, here, let me show you another shortcut. I know I want to run the compiler, and the compiler command was clang++. I can use my arrow keys to go backwards through my history, but another way I could do this, if I push Control R, it will search. It allows me to search through all my commands. So I can type C, and it finds the first command that started with a C, and there it is, clang++. And I can hit Enter, and I just ran the compiler. It's really convenient. There's all sorts of tricks to allow you to get stuff done fast and efficiently in the terminal. There you go. Makes sense. So this gives us an idea of how we can write programs with Visual Studio Code as our text editor, our terminal as the way we compile and run our programs. But it's really important that you make sure that you have all the tools installed, because if you don't have the tools installed, you're going to find that the command's not there. Now, the way you know the command's not working is if you type a command, let's say, for instance, our compiler's name was clang minus. Let's imagine that's the compiler's name. If we run that command and the computer says command not found, that means that tool's not installed. And if it's not installed, try running that script again. And if you run into problems, talk to your instructor, talk to your TA. Somebody will help you get things shipshape and oriented and everything working out just fine. Now, I wish we could have done this together in a classroom, because I'm certain some of you would have had questions. But, you know, we'll have class soon, and you can ask me questions about how to write these programs. There's other videos that do cover how to do stuff with Git. Git's a very important tool. All of our labs require you to use Git. So please watch those videos, and when the next lab comes out where you're going to be cloning something, cloning is where you copy it from Git. When you do that activity, just be patient with yourself and don't rush. You'll get the hang of it. Now, when you're done working on something, make sure your work is saved. Make sure that you save all your stuff, and then you can just close these windows. They'll just go away. And over here in the terminal, these files are here, and if you ever get confused where you're at, you can always go back to your home directory by just typing CD, type ls. And if you're not comfortable, remember you can always do the double clicky thing and navigate through your computer this way. So that way you can observe, just verify, oh yeah, those are my files. They're right there. They're in a folder called CPSC 120. Good, I've got everything organized. Be patient. Keep on trying. You'll get the hang of it. It's not that hard.